All right, section 10.2 talks about graphing linear equations. Now, for the most part, this is something that you had in Math 98, graphing linear equations. And we're going to do this part using a t-table. So when you get your worksheet, it will say use a t-table. So you must use a t-table. You must show the t-table. Okay? So keep that in mind. The way I do in class is the way you need to do on the worksheet. So if it says do a t-table, you show the t-table. Okay, so in the word linear, you also see the word line, right? So if I graph this linear equation, what you're graphing are lines. So these are lines that you're graphing. Now a linear equation has this form. It'll look something like some number times x plus some number times y equals some number. That is the form of a linear equation. Notice you see both the variable x and y. You see both x and y in there. And if you look at the exponent, and you got to remember what I mean by exponent. Like if I have 5 to the third power, what's my exponent here? 3. That's your exponent. And by the way, the 5 is called your base. If you don't see an exponent, what is it understood to be? No, 1. 1. So if there's no number there, it's understood to be 1. So this is a times x to the first power plus b times y to the first power. So what makes it linear is that the exponents for both the variables are 1. So next class period, or probably the class period after that, you're gonna start graphing a quadratic function. So in that case, it's not linear anymore. It will be a parabola. So we'll talk about that. So in that case, the exponent will no longer be 1. It will be something else. All right. You're also going to see, we're also going to graph something in here that's going to have this form. It will be something like y equals mx plus b. So where y is by itself. So notice here, this form right here, the variables are on the same side. Here, y was by itself. Now you may remember from a previous course that when y is by itself, this is called slope-intercept form. So that's called slope-intercept form. Now that's not our focus for this. Our focus here is just to graph any linear equation using a t-table. But you are going to graph somewhere y is by itself, and that's called slope-intercept form. And we're not even going to mention the idea of slope or a y-intercept in this part. So that's not the focus of this part of the lesson. The focus of this part of the lesson is just use a t-table. That's all it is. All right? So let's look at number 1. When we do number 1, where you have this linear equation, x minus y equal 4, x minus y equal 4. In my math lab, when you do my math lab, they're going to give you a t-table. They'll give you a t-table. And this is your x column, this is your y column. And they're going to give you some values for x and y. And it'll be 3 values. And so let's suppose x is 1. We have to find the y value. If y is 3, we have to find the x. If y is negative 1, I'm sorry, if x is negative 1, we have to find y. So in my math lab, you're going to see a t-table where in some cases you're told what x is, and in some cases you're told what y is. And then you just have to find the other value. There's probably one on my math lab like this, where you're given an x value or a y value, you have to find the other value. But regardless, if x is 1, what do I need to do to this to find the y value? Right, wherever you see the value x, what do you plug in? 1. So I have 1 minus y equal 4, right? And then all you have to do now is get y by itself. So what's the next step? No, not add 1. Now, mathematically, adding 1 to both sides is correct. You can't do that, but is that going to help you? No, because when I add 1 to both sides, that becomes 2 minus y equals 6 now. That doesn't help. I'm sorry, equal 5. That doesn't help. You want to get y by itself. So what's the next step? Subtract 1. Subtract 1, and now that helps because what's 1 minus 1 when I combine those like terms? 0. And then what's 0 minus y?
Minus y.
Negative y. Equal, and then 4 minus 1 is 3. So that's where I'm at. But remember, you got to get y by itself. Negative y is the same thing as being written as what? Negative 1y. So I get negative 1y equal 3. So it's a good idea for some of you to write it as negative 1y. Now, the negative 1, remember, is called the coefficient. The negative 1 is called the coefficient. The coefficient is the number you're multiplying the variable by. So right now, what's the coefficient of y?
Negative 1.
Negative 1. If I want to get y by itself, right now, multiply by negative 1, right? What's the opposite of multiplication? Division. So I divide both sides by the coefficient. So I'm going to divide both sides by what? Negative 1. All right, so it's not negative 1y you divide by, it's just a coefficient, negative 1. And then you reduce. Negative 1 divided by negative 1 is a positive 1. 1 times y is y. That's probably what you meant. Y. And y equals a negative 3. So I found the y value. The y value is negative 3. All right. Now what I also found, though, is a solution to this equation. I've also found a solution. So remember, in a previous course, when you asked to solve x minus 3 equal 4, what value for x will make that equation a true statement? What value for x makes that equation a true statement right here? 1 minus 3 is not 4. Guys, what is x?
Change the sign.
Well, what is x? What's that number? 7. What's 7 minus 3? 4. Right? So basically, you were to add 3 to both sides. So x equals 7 is a solution. So here, when I plug in 1 and negative 3, notice what happens when I substitute 1 and negative 3. X is what value? No, here. X is what value? 1. Subtract y, what's y? Negative 3. And I want to see if that's going to equal what number? 4. Okay? Well, 1 subtract negative 3 means the same thing as 1 plus what? 3, which is what? 4. So that equation is a true statement, so this is a solution, just like this was a solution. So whenever you're finding your point, you're finding solutions. So these are solutions.
Every
That
point
equation.
is the solution, or is it possible that the point cannot be a solution as well?
The point would not be a solution if you made an error. So if it's a solution, it's going to satisfy that equation. Okay?
So every single point is a solution.
Every point that you find that makes that equation a true statement is a solution. That's correct. All right, so let's find the other solution. How many solutions are there altogether, though?
3.
Oh, no. An infinite number. I'm just using how many? 3. Because I can keep on going, right? I can say, suppose x is 4.2 if I wanted to. You can use decimals, you can use fractions, and all that. So there's an infinite number of solutions. To graph a line, how many points do you really need?
2.
2. You need 2 points to graph a line, but you could have made an error, right? Some of you could have said here, when we did this, some of you could have said y is negative 2. That would have been an error. You still would have put negative 2. Plot 2 points, draw the line. It's the wrong line. You graphed the wrong line. So that's why we always try to use 3, because all 3 points better lie on the same line. If they don't, one of them is an error. or 2 could be an error. They all could be errors. Okay? All right, so let's find the other point. So this time, what is y? 3. So if y is 3, I go to the equation. Wherever we see the variable y, I plug in 3. So I'm going to get x minus 3 equal 4. Well, actually, we already did that one. How do you get x by itself? Add 3 to both sides. So it's x? 7. So x is 7. So 7, the point 73 is also a what? Solution. That's also a solution. All right, we need one more. So let's say -1. X is -1. So I get -1 subtract y equal 4. -1 subtract y equal 4. All right, to get y by itself, what's the next step? Add 1. Very good. Not subtract 1. That's not going to help you. Because what's a -1 and a -1? -2. That didn't help. Adding 1 helps. Add 1, add 1. Because what's -1 plus 1? 0. And 0 minus y? Negative y, just like we did here. 0 minus y, negative y. Equal what? That's a y. Equal 5. All right, using that same idea here, you may want to rewrite this as -1y. All right, what's the next step? Divide both sides by -1. -1 divided by -1 is 1. 1 times y is y. What does y equal? -5. So I found another solution. Another solution is the point -1, -5. So when we plot those points and we graph the line, you're really graphing solutions. That's what we're graphing. We're graphing solutions. All right, so let's go ahead and plot that point. Plot those points. Let's graph the line. So on your grid paper, you're going to plot those 3 points. And so remember, though, when plotting a point, you always start at the origin. Where is the origin in a coordinate plane? Yeah, in the middle, meaning where the x-axis and the y-axis intersect. So the x and the y-axis intersect here. So when plotting a point, always start there. The first point is the point 1, -3. So x is +1, right? So that means that from the origin, I go which way? To the right 1. Don't put a dot there. You're just going to the right 1. So that's your x. Your y is a -3, so I go down 3. So if x is positive, you go to the right. If x is negative, you go to the left. If y is positive, you go up. If y is negative, you go down. Just like on the x-axis and the y-axis. Notice that these x values are positive, these x values are negative, these y values are positive, these y values are negative. All right, so the point 1, -3 is right here. Now, on the worksheet, if it says label, remember what labeling means. Label means to indicate what those coordinates are. So you're going to write it like this. You're going to say 1, -3. That's labeling. Putting the dot is plotting. You plotted that point. But labeling is where you actually tell me what the x and the y coordinates are. All right, the next one. Oh, and by the way, what quadrant is this point in? 4. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So 1, 2, 3, 4. All right, the other point was 7, 3. So x is 7, you start at the origin. X is 7, you go to the right 7, and then up 3, right? So there's the point, 7, 3. The next one is -1, -5. So you start at the origin, you go which way? To the left, and then down 5. So there's the point, -1, -5. All right, so then you would take a straight edge, and then you would, now on the worksheet, you're going to use a ruler to graph the lines. Don't do it by hand. You're going to use a ruler. Just take one. Right. I need these rulers back. Don't take them home. They have tracking devices on them, by the way. All right, now when you draw the line, make sure you extend it through those points, just like this. Just extend it. And then the other thing you got to remember to do is to draw the arrow. Draw the arrow. Some students forget to draw the arrow. You need some more rulers? Is that what y'all need?
Yes, sir.
It was just us two
It's
right now.
three. It's three.
Okay, now one thing I got to mention, every point that's on that line is a what? Solution. So this point that I'm pointing to right here, is that a solution?
No.
No. So all these coordinates, all these points are not solutions. Only the ones that are on this line. So how many solutions are there? An infinite number. Not 3. You labeled 3 points. You plotted 3 points, but there are how many of them? An infinite number. Okay? So the infinite number of solutions. All right, so that was that one. Let's look at the next one. Okay, number 2, we have all right, so number 2, you have this linear equation. Now this time y is by itself, but you'll notice that the coefficient of x is a fraction. So since the coefficient of x is a fraction, you want to be strategic in the numbers you use for x. Yes?
What's happening to
Yeah, it's kind of like,
chilling on
Larry, it's not wanting to focus.
No. Let's see.
Okay.
I'm not sure what's going on.
Machine is getting old.
It's possible. Okay. All right. So you want to choose numbers that are divisible by 3 by the denominator. So when you do these, when y is by itself and you have a fraction for the coefficient of x, choose numbers that are divisible by 3. If you don't, here's what's going to happen. Let's say you let x be 4. So then you would have to figure out, well, first of all, negative 2/3 times 4 is negative 8/3, right? Then you have to add that to 5, meaning that you have to find the LCD, and then you'd have to plot a fraction in the coordinate plane. So you'd have to estimate where that is. So rather than dealing with fractions, we're going to choose numbers for x that are divisible by this denominator, by 3. So what numbers are divisible by 3? What's the easiest one to use? 0. Not 1. 1's not divisible by 3. So numbers divisible by 3 are 0, 3, negative 3, 6, negative 6, 9, negative 9, and so on. You know what I mean by divisible? Okay, but 0 is always divisible by a number other than 0. So 0, 3, negative 3, and I'm going to say 6 as well. So those are the ones we're going to look at. But all you really need 2 points to graph a line, but you could make a mistake, so always use 3. I'm using 4 here, so I can use that 6. But you understand by divisibility. So if this was, let's say, 7, if my denominator was 7, then you'd say 0 and what else? 7, negative 7, 14, negative 14, and so on. Okay. All right. 0 is always easy to use because when you let x be 0, I get negative 2/3 times 0 plus 5. Now remember your order of operations. Order of operations, here you have multiplication and then addition. What do you do first? Multiplication. Any number times 0 is 0. And what's 0 plus 5? 5. So I have a solution, 0, 5. Okay, let x be 3. If x is 3, I get y equals negative 2/3 times 3 plus 5. Negative 2/3 times 3 plus 5. All right, so let's kind of review some multiplication of fractions. So I'm going to go off to the side. And remember, I can write 3 as 3 divided by 1. Okay? We also need to remember that a negative times a positive is a negative. Now, one of several things you can do. You can multiply the numerators first. You can multiply first, or you can reduce first. Let's multiply first. What's negative 2 times 3?
Negative.
Negative 6. What's 3 times 1? And then reduce. What's negative 6 divided by 3? Negative 2. Negative 2. So this is negative 2 plus 5, which is, what's negative 2 plus 5? 3. So I found another solution. The other solution is 3, 3. Now remember though, you could have reduced first. What I did was I multiplied first and then I reduced. You could have reduced first. 3 to 3 is 1. 3 to 3 is 1. Negative 2 times 1 is negative 2. 1 times 1 is 1. Reduce, you get negative 2. All right, so it doesn't matter which approach you use, you get the same value. All right, let's do negative 3. If y is negative, if x is negative 3, I get y equals negative 2/3 times negative 3 plus 5, right? We do multiplication first. What's a negative times a negative? Positive. All right, so let's go off to the side and kind of figure this part out. So that's negative 2/3 times negative 3 over 1. I can do the same thing I did here. If you want to multiply first, you can. What's a negative 2 times a negative 3? Positive 6. What's 3 times 1? 3. Took y'all a while to say 3. 3 times 1 is 3. What's 6 divided by 3? 2. You could have reduced first if you wanted to. 3 to 3? 3 to negative 3? Negative 1. What's negative 2 times a negative 1? Positive 2. 1 times 1? And you get 2. So again, it doesn't matter what approach you take. But this is 2 right here though, right? And 2 plus 5 is 7. So I get the point negative 3, 7. And let's do the 6. If x is 6, I get y equals negative 2/3 times 6 plus 5. So let's kind of figure out what this is. So I'm going to go off to the side, negative 2/3 times 6 over 1. If I reduce first, I can. If you reduce first, you'd say 3 to 3 is 1. 3 to 6 is 2. Negative 2 times 2 is negative 4. 1 times 1 is 1. So you get a negative 4. If you did not want to do that, you could have just multiplied first. You could have just multiplied first. What's negative 2 times negative 6?
Negative 12.
Positive 12. Negative times a negative. 3 times 1? Oh, it was negative 6. I see what you're saying. No, it's me. No, you're fine. I said negative 2/3 times negative 6, right? No one said anything. It should have been a what? Positive 6, yes. Okay, now you're right. Negative 2 times 6 is a negative 12. And what's negative 12 divided by 3? Negative 4. All right, so that becomes negative 4 plus 5, which is 1?
Yeah.
All right. So then I plot those points in the coordinate grid. And so I get 0, 5. Now remember 0, 5. So I start the origin, x is 0. So do I go right, left, or stay? I stay at the origin. Y is a positive 5, so that means I go up 5. So here's the point, 0, 5. And that is on the positive y-axis. So it's not in a quadrant. 0, 5 is not in a quadrant. It's not in 1, 2, 3, or 4. It's on the positive y-axis. The other point was 7. Nope. The other point was
Negative 3, 7.
Negative 3, 7, all right.
No, 3 and 3.
Three, 3, right? But one of them was negative 3, 7, yeah. Negative 3, 7 was the other one. But the next one was 3, 3 that we had. So 3, 3, right 3, up 3. Plot, label the point. Then negative 3, 7. So go to the left 3, up 7. And notice that they are going to lie in the same line. And then 6, 1, we did 6, 1, so let's go ahead and do that. So 6, 1, go to the right 6, up 1. All right, so there are my points. If I draw the line, they do lie in the same line. Extend it far enough to where it goes to those points, and then draw your arrow. And so that's the line, y equals negative 2/3 x plus 5. All right. Okay, the next one, suppose we had number 3. Now you have 2 grids on the back page, so use the back as well. All right, number 3, suppose
So can I ask you a question?
yes,
So whenever you're dealing with a fraction, you just find the,
number divisible by the denominator.
okay.
Okay, so I have y by itself. The coefficient of x is a fraction, so you want to be strategic. Don't just pick any number for x. Choose numbers for x that are divisible by what? Which is 5. All right, so we're going to choose numbers for x that are divisible by 5. 0, 5, negative 5. So we'll just use those 3. You could say 10, negative 10, 15, negative 15, and so on. Now, one of the things you want to do, though, whatever the size of your grid is, you want to make sure that your point fits in here. Now, one of the worksheets you can get today, I think is the last one, it doesn't fit in the grid. So just expand the grid, extend it. You're going to see what I mean when you get to it. I didn't give you a grid big enough. Okay, so if x is 0, I get y equals 1/5 times 0 minus 2. What's a fifth of 0? 0 minus 2? Negative 2, right? If x is 5, I get y equals 1/5 times 5 minus 2. All right, so let's do this multiplication just like we did in the previous problem. 1/5 times 5 over 1. If you want to multiply first, you can. 1 times 5 is 5. 5 times 1 is 5. What do I get? 1. And what's 1 subtract 2? Negative 1. So I get the point 5, negative 1. If x is negative 5, I get y equals 1/5 times a negative 5 minus 2. So I do multiplication first. I kind of figure out what 1/5 times a negative 5 over 1 is. Remember, a negative times a positive is a negative. All right, if I want to multiply first, I can. What's 1 times a negative 5? 5. The denominators, what's a positive 5 times a positive 1? So what do I get? Negative 1. Now this time, though, that's a negative 1 subtract 2. What's negative 1 subtract 2? Negative 3. Negative 3. So it's like saying a negative 1 and a negative 2. So a negative 1 and a plus a negative 2 is a negative 3. So then I plot those 3 points. And I get, so 0, negative 2. So x is 0, I stay at the origin. Y is -2, I go down 2. Remember, labeling means to actually state the coordinates. So this is 0, -2. 5, -1. I start at the origin. I go which way? For 5, which way do I go? No, not to the left, to the right. To the right, 5, and then what? Down 1. Okay, I label that point, so that's 5, -1. And then the other one is -5, -3. So I start at the origin. I go which way? To the left 5, and then what? Down 3. So there's the point, -5, -3. And notice that those points are going to lie in the same line. So draw that line, extend it through those points, away from those points, and don't forget to draw your arrow. So this is a line, y equals 1/5 x minus 2. That's that line. All right, now notice in the 3 problems we did, there was both an x and a y variable, correct? Look at all of them, you'll see a y and an x in that equation. The next one we do, number 4, we look at number 4. You have y equals 3. What's missing here? Your x. So x is missing. But it's still linear. This is still a linear equation because y is being raised to what power? The first. Y is being raised to the first power. So it's still a linear equation. Now, what that equation is saying is this. This is saying that y is always equal to 3. That's what this is saying. Y is always equal to 3. In the previous one, there was a variable x associated with it. So this says that y is always going to equal 1/5 of whatever x value I use, right? And subtract 2. So that's why you notice that these y values were different each time, because my x values were different. Here, this is saying that y always equals 3 no matter what x is. That's what that says. Y always equals 3 no matter what x is. So if I use the t-table, then that means in the y column, what is y always going to be? 3. So you have 3's all along here. That's what you're going to have. And x can be any number. So x could be what? 0. X would be what? 1. X would be 2. X would be -3, and so on, right? Does not matter. So if I plot those points, notice what we get. So I get 0, 3. I get 0, 3. That's on the positive y-axis, so 0, 3. I have 1, 3. I have 2, 3, and so on, right? So if I draw my line, notice y equals 3 is what kind of line? Now, I'm looking for a certain word. What kind of line is this? Do you remember that word? Horizontal. So that's a horizontal line. So y equals 3 is a horizontal line. Just like your x-axis is horizontal, your y-axis is what? Vertical. Your y-axis is vertical, your x-axis is horizontal. All right, so if y equals a number, you know how to deal with that.
Excuse me, the last mark is -3, not +3. I'm sorry.
I'm sorry? What'd you say?
It's supposed to go to the left, not to the right.
What's supposed to go to the left?
You just didn't add the last one.
The last x value.
Okay, okay, that's fine. -3, 3 is still in that line, right?
Yeah, right.
Okay, yeah. I just plotted 3 points, but he's saying I had 4, so let's plot 4. That's what he's saying. All right, so any questions on that, though? All right, let's look at this one. All right, number 5. Let's suppose we had x equal -6. X equal -6. All right, now this is still linear. This is still a linear equation. So when I graph it, it's going to be a line. Because x is being raised to what power? The first. Just like in number 4, in number 5, there's a x variable, but there's no y. Okay, no big deal. I can still deal with this. You're gonna think about it the same way you did number 4. So number 5, this is saying that x is always equal to what? -6, no matter what y is. So compare that with number 4. So in the t-table, for the x column, you're going to have what number? -6, all the way down, and so on, right? No matter what y is. So y could be 0, y could be 1, y could be 2, y could be -4, and so on, right? Does not matter. But this makes sense because this says x has to be -6, and that's what x is. If you look at all these points, x is -6. And so if I plot those points, now, notice I get, all right, so it's -6, 0. When we start at the origin, x is -6, so I go to the left 6. Y is 0, so do I go up, down, or stay?
Stay.
I stay. So -6, 0 is on the x-axis. -6, 1. So I go left 6, up 1. -6, 1. And let's just do the -6, -4. -6, -4. I go to the left 6 and then down 4. I'm not gonna plot all 4. I just needed 3 of them. -6, -4. And notice if I draw the line, they all lie in the same line. So if you did all 4, they would all lie in the same line. And so make sure you extend it, draw the arrow. All right, this time, what kind of line is this? Vertical. So it's a vertical line. So x equal a number is always going to be what kind of line? Vertical. Y equal a number is always going to be what kind of line? Horizontal. So in my math lab, they ask you questions like that about vertical lines and horizontal lines when we get to it. Okay? All right, now let's look at number 6. Oh, by the way, one thing I want to mention. So notice that when we did with the first 3, and I think number 1 was x minus y equal 4. Okay, so we did the first 3. So notice that this line here had 2 variables in it, right? You could see it. So did this line. So whenever you have 2 variables, notice, and again, you read a graph from left to right. As you go from left to right, this line is rising. This line is falling, decreasing, falling. I have 2 variables here. This line is rising. But if there's one variable, if there's one variable, and this was y equal 3? If there's one variable, either it's horizontal or it is going to be vertical. So two variables, you get the slanted line, either rises or falls. One variable, it's either horizontal or vertical. If it's y equals a number, it's what?
It's a horizontal.
Horizontal. If it's x equal a number, and this was x equal -6, if it's x equal a number, it is vertical. All right, so we do the next one then. Number 6. You have y plus 2x equals 3. So if I were to graph this line, is it going to be slanted or is it going to be either horizontal or vertical? It'll be slanted. Now, what you want to do though, the best way to do this is to get y by itself. So let's go get y by itself. Now, when you get y by itself, what are you going to do to both sides? Subtract 2x, because right now you're adding 2x. What's the opposite of adding 2x? Subtracting 2x. And subtract 2x on both sides, just like this. What you do one side, you do the other. Then you combine like terms. What is 2x and a negative 2x? 0. What's y plus 0? Y. Now be careful here. Are these like terms that I'm pointing to on the right-hand side? No. So you're not going to say that's a negative 6x or a negative 5x or 1x, whatever you want to say, because that's not a 3x. That's just a 3. So how are you going to, and go ahead and put x first. So how are you going to write this side? Very good. Negative 2x plus 3. That's how you write this. Negative 2x plus 3. And now you do the t-table. Do I have to worry about fractions? Do I have to worry about the divisibility rule? No. I can use any number for x. So you do your t-table. If x is 0, and again, you can skip some of this. You don't have to show all this work. I do need to see the t-table, though, because it does say do this by using a t-table. So I get y equals negative 2 times 0 plus 3. What's negative 2 times 0?
0.
0 plus 3 is 3. All right, give me another number for x. 1. If x is 1, I get y equals negative 2 times 1 plus 3. What's negative 2 times 1? And what's negative 2 plus 3? 1. And then finally, let's do one more. I'm going to use 2, okay? If x is 2, I get y equals negative 2 times 2 plus 3. What's negative 2 times 2? And what's negative 4 plus 3? Negative 1. Right. So if you don't remember your signed rules, use your calculator. Negative 4 plus 3 is going to give you negative 1. If you need to review your signed rules, just go to YouTube and just Google something like adding signed numbers or subtracting signed numbers or multiplying signed numbers, and you get all these videos. All right. So if you need to review that way, you do that. Look at videos.
So when you turn to the worksheets, you don't want to see all the work, you just learn.
No, I don't need to see all that. I just need to see the t-table. I have to see the t-table. Now, showing all this, though, will help me if there's an error here. If there's an error, then showing this can help me to tell you where your mistake is. Okay? You understand? All right. Okay, so then we plot those 3 points. Plot those 3 points. So number 6. If you need some grid paper, there's some up here if you need some. All right, so number 6, you have 0, 3. So 0, 3 is located where?
On the x-axis.
Not on the x. Oh, 0, 3, 0, 3. Where's 0, 3? On the y-axis. Y-axis. All right. So 0, 3. 1, 1 is in quadrant 1. 2, negative 1 is in quadrant where? 4. Quadrant 4. Remember, labeling means just what I did. I indicated what these coordinates are. All right. Now, don't forget, you're not done yet. All you did was just plotted 3 points. You need to draw the line.
And the arrow.
Yep, and the arrows. All right, you get this. So there's your line. So that's the line. Y plus 2x equals 3, or you could have said y equals negative 2x plus 3. Does not matter. That's that line. All right, and then let's look at this one. This is number 7. We have 4y equals negative 5x plus 8. So 4y equals negative 5x plus 8. So remember, you want to try and get y by itself. It does help. It makes things a lot easier if you can get y by itself. I don't have y by itself. I have 4 times y. So what's the coefficient of y right now? 4. Divide both sides by 4. Yeah. So I'm going to go ahead and rewrite this over. So I'm going to divide both sides by 4 just like this. What you do to one side, you do the other. The left side's easy to deal with. The left side, because you know that 4 divided by 4 is 1. 1 times y is y. All right, let's talk about the other side. Okay, so let's kind of review something. If I have 10 plus 2 divided by 2, let's suppose I had that. Just kind of review. 10 plus 2 is 12. 12 divided by 2 is 6. But do y'all all agree that I can also write this as 10 divided by 2 plus 2 divided by 2? So basically what I did was I took every term that was in the numerator and I divided it by the denominator. And 10 divided by 2 is 5. 2 divided by 2 is 1, and I get 6. So using this idea, I can do that here. So I can take every term that's in the numerator and divide it by 4. So I get negative 5x divided by 4 plus 8 divided by 4. But what's 8 divided by 4? 2. So I get y equals negative 5 fourths x plus 2. And now that looks like 2 of the problems we had earlier. So you want to choose numbers for x that are divisible by 4. Choose values for x that are divisible by 4. 0. If x is 0, I get y equal negative 5 fourths times 0 plus 2. What's negative 5 fourths times 0? And what's 0 plus 2? 2. Get 0, 2. If x is 4, I get y equal negative 5 fourths times 4 plus 2. All right, let's think about what negative 5 fourths times 4 is. It does help for some of it, because some of you want to say 4 times 4 is 16. That's not what you do, right? You don't say 4 times 4 is 16. So if you're inclined to do that, then you need to write this. You need to say negative 5 fourths times 4 divided by 1. And then we multiply the numerators together. What's negative 5 times 4? Negative 20. And then what's 4 times 1? 4. And so what is negative 20 divided by 4? Negative 5. And so this becomes negative 5 plus 2, which is, what's negative 5 plus 2? Negative 3. All right, now give me one more value for x. What do you want to use? Huh? 8?
Negative 4.
Yeah, I think 8 would be outside that grid possibly.
Negative 4.
No, I mean, eight would still work. I mean, we could use 8, but let's do -4. Eight would work because look, what's negative 5/4 times 8? Negative 5/4 times 8,
Negative 40 over 4,
which is negative
10.
-10. And what's -10 plus 2? -10 plus 2, -8. And so -8's inside that grid. So you could have used -8. All right, -4 or 8 rather. Okay, -4 you have y equal -5/4 times -4 plus 2. All right, so let's kind of figure out what -5/4 times -4 is. So -5/4 times -4/1. A negative times a negative is a positive. What's -5 times -4? What's 4 times 1? And what do you get? 5. So that becomes 5 plus 2, which is 7. All right, and so then we plot those 3 points. We draw our line. So 0, 2. 4, -3. And then -4, 7. -4, 7. All right. -4, 7. So then you draw your line. And you get this. Okay? All right. Okay, so that's going to take care of that first worksheet that you're going to get. So in a little while, I'll give you that worksheet, but make sure you use these problems to do that worksheet. You can do just like we did these. All right. Now, the other way you can graph a linear equation is use intercepts. Now we're going to do intercepts. We're actually going to do the graphs next class period. But let's kind of remind ourselves what intercepts are. What intercepts are. Okay, so these are intercepts. All right, so we're going to talk about graphing lines, graphing linear equations. Using intercepts. Okay, using intercepts. Now, if I go back and talk about this line right here, you see where I have this 0, 2 right here? See that right here? What do you notice about that line? That line crosses the y-axis at this point, right? So that point here is called a y-intercept. So the y-intercept is where the graph crosses the y-axis. So the y-intercept is where the graph crosses the y-axis. All right, well, if I look now at that same line, but this point I'm pointing to right here, notice that's the point where the graph does what right here? Crosses the x-axis. So that point we call the x-intercept. So the x-intercept is the point where the graph crosses the x-axis. X-axis. So the y-intercept is where the graph crosses, the point where the graph crosses the y-axis. The x-intercept is the point where the graph crosses the x-axis. Now, one thing I want to remind you, I'm going to draw some lines, Notice what I'm doing. I'm drawing these lines right here. See this line that I just drew? Don't worry about the arrows. But this line I just drew, this point right here is called the what? Y-intercept. If I label that point, y'all agree that's 0, 7? Okay, let's look at this one. If I draw this line, this is also a what? Y-intercept. That point has coordinates 0, what? 3. If I look at this line right here, that's a y-intercept. That has what coordinates? 0, -4. Okay, so when I'm looking, all these are y-intercepts, right? What do you notice about what they have in common? What do they have in common?
X is always.
The x is always 0. X is always 0. So we're gonna do this next class period to find. Well, let me write it this way: the y-intercept, x is what? 0. X is 0. All right. One more thing. Let's look at a graph that crosses the x-axis. Let's look at that. So all these right here. So this point is an x what? Intercepts. And if I label that point, that's -6, 0, right? Okay, if I look at this one, this is 2 what? 0. If I look at this one, this is 8, 0. But all of those are x-intercepts, correct? So if you notice about your x-intercepts, what do you notice about the y's this time? All are 0. So the x-intercept, y, is 0. So you're going to use that idea in the next lesson. So to find the y-intercept, or when the graph crosses the y-axis, what is always 0? No. The x. No, when we're looking at a graph that crosses the y-axis, x is what? 0. A graph that crosses the x-axis, y is 0. And don't memorize this. Just draw a line through the y-axis and then ask yourself, what's that point? You're going to notice that x is 0. Draw a line through the x-axis and ask yourself, what's that point? You're going to notice that this time y is 0. Okay? All right. Okay, so that's the end of this part. Let me give you that first worksheet.